So now we're going to use SkatePark physics again, and we're going to use it to investigate friction and how it interacts with potential and kinetic energy. So without further ado, you're going to go back to that same simulation that we did last time, but this time we're going to be playing with this part of it here, the friction slider, because we're going to be trying to answer the question of what happens to skaters' potential energy as they progress if you turn on friction. You look at your graph on the side here, you're going to have to look at it. What happens to the potential energy if you have no friction as the skater goes up and down like that? What happens to the potential energy each time they do a circuit of that skate park there? And then we're going to start changing that friction and leaving everything else the same. Now, just to keep all our variables the same, I actually this time set it to 50 kilos, simply so that our graph looks a little bit bigger than what it did before. Okay, so you can set it to 50 kilos and make it a little bit easier to actually visualize what's happening there with your graph. And we're going to do a few changes. So first thing is, I wanted you, to view it when there is no friction. Then I want you to do it when you've set the friction sort of midway. Lastly, I want you to view it when you've set the friction to lots. Okay? Now, and then I want you to go into your Google Docs and answer the question, what happens to the potential energy when we have friction at play? Now, there's a better way to actually view this, and that is using the graphing section of this. So see this little one down here you'll see at the bottom of Phet? Instead of using intro, I want you to go and click on graph, and this comes up. Again, I need you to make sure you turn on this energy graph here if it's not turned on. I need you to set it to time. Stick to the track, and make sure you leave gravity at Earth's gravity, and we're going to try and leave their mass at 50 kilos. Okay? And then we're going to run a few simulations, and we're going to run it for about 20 seconds. And at the end of that 20 seconds, I suggest you take a screenshot that you can even add into your Google Docs in your question section, so you've got pictures of what it looked like for each one of these simulations. The questions you're going to be answering are, what happens to the kinetic energy as your simulation progresses when friction changes basically, or is in play? So the very first simulation you're going to run is where friction is set to 0. So the very first thing you're going to do is make sure, number one, that your friction is set to 0. And you're going to run the simulation for 20 seconds. Then I want you to take a screenshot. And that can actually be uploaded into your Google Doc, so you can look at it later on as you answer these questions. You can actually upload it straight next to the question. Then I want you to tick or click the rubber button here, and it will actually clear your graph for the next simulation. So then I want you to move, number 2, your friction to the midway here and run it again. And again, we're going to run it for 20 seconds. Take a screenshot, and once you've done that, you can then tick the rubber there and clear it for the last simulation. Last but not least, I want you to click it to lots. Again, run the simulation for 20 seconds and screenshot. And you can add them into your Google Doc and answer the question. So the question is, what happens to their kinetic energy? Then what happened to their thermal energy as you increase the friction? Okay? Last question. Why has the kinetic and potential energy changed throughout the simulation? You'll notice when you look at your graphs that the amount of kinetic and potential energy changes, but the total amount doesn't. You need to actually talk to me about what has happened and why they're changing throughout the simulation. So once you've done that and answered those questions, entered your screenshots, get your teacher to check your work, and if there's time you can have a play on the playground in SkatePark Physics.